honorable guests, and everyone present. We are proud representatives of the Corner Brook School. My name is Vanya Cherop.
My name is Gloria Ashley.
And we are here to present our project entitled
Solar-Powered Water Purification System.
Access to clean and safe drinking water has become a major challenge in many parts of Kenya, especially in rural and arid regions. Water sources such as rivers, dams, and boreholes may contain dirt, bacteria, and harmful microorganisms that may cause waterborne diseases such as cholera, typhoid, and bilharzia. Kenya receives abundant sunshine throughout the year. This project explores how solar energy can be used as a sustainable and affordable solution to purify water without relying on electricity or expensive chemicals. As I said, many communities in Kenya lack reliable access to clean and safe water sources. That's why conventional purification systems may require electricity, fuel, and costly filters which are not accessible to low-income households. That is why we have come to answer the question, can solar energy be used to design a low-cost, efficient water purification system that is suitable for many rural communities in Kenya?
Many areas in the world lack access to safe drinking water. That is why we came up with our project, Solar-Powered Water Purification System. It uses energy from the sun to clean contaminated water.
This system often works through solar distillation. As you can see from our diagram over here, solar distillation is whereby when the sunlight hits the water, causing it to evaporate, the water vapor then condenses onto the cool glass sheet, which is then turned into clean water, and it leaves impurities behind.
Solar water purification is environmental friendly, affordable, and sustainable method for providing clean water, especially in areas with plenty of sunlight.
Our aim in this project is to design and construct a solar-powered water purification system, to test its effectiveness in removing impurities,
to evaluate its stability for use in rural areas, to promote renewable energy solutions for community development.
Our hypothesis is, if contaminated water can be heated using solar energy in a solar water purifier, then the clean water can be produced through evaporation and condensation.
Materials used. You need a black fiber laboratory sink, silicone glue, a quarter kg of iron nails, block board, sample of tap water, block board.
Okay, some of the background information that we received is the solar water purification works using two main principles. A, solar distillation. As I said, the sun hits the contaminated water, causing it to evaporate and turn into water vapor. The vapor then condenses onto the cool glass sheet, which is collected as clean water. B, solar UV disinfection, also known as SODIS. Sunlight, especially ultraviolet rays, also known as UV rays, kills harmful microorganisms in water when exposed for several hours in sunlight. This project mainly focuses on solar distillation as it removes salts, bacteria, and other contaminants.
Methodology. Step 1, construction. Cut the blockboard into the required sizes. Drill holes into the blockboard to fit the PVC pipes. Attach the 6 boards together using nails. Fill the empty space between the sink and the block using pieces of cloth. Attach the glass sheet using silicone glue. Paint the edges of the glass sheet using white paint. Tighten the PVC pipe.
Step 2, experiment. Place the system under direct sunlight for about 4 to 6 hours. Observe evaporation and condensation. Measure the amount of clean water collected and compare appearance and smell before and after purification. The results of our project, the system successfully produced clear water after several hours under sunlight.
The purified water was clean and left no particles.
The volume of clean water depended on sunlight intensity and duration.
Higher temperatures increased evaporation rates.
Okay. Kenya's sunny climate makes solar distillation highly practical. Areas such as Turkana and Marsabit experience high temperatures and water scarcity. They could benefit greatly from this system.
Advantages: it uses clean and free solar energy. No electricity or fuel is needed. For example, in our country, fuel prices have reached. Due to this project, we are able to save a lot of money. It is easy to build and maintain, environmental friendly, is used in homes, schools and remote areas. In our school, we use a lot of water to wash our hands. Due to this project, we are able to save a lot of money. Conclusion. The solar-powered water purification system is an effective, low-cost and environmental-friendly solution for improving access to clean water in Kenya. With improvements in design and scaling, it can help reduce waterborne diseases such as typhoid, cholera and diarrhea, and supports sustainable development in rural communities.
If you are to make this project, I would recommend that you increase surface area to produce more water, use stronger insulating materials to retain heat, and educate communities on solar purification methods, and combine filtration systems for better efficiency. Some of the limitations of this project are, it's a really slow process, for we put it in the sun for 4 to 6 hours, produces small quantities at a time, and depends on weather conditions. For example, if it's really sunny, we cannot put our project in use. Thank you. Any questions can be asked.
Thank you for your presentation. Where's the project?
It's outside, you can go see it. We just put it under sunlight for it to be.
So it's outside.
Yeah.
How much water does it produce in a day? When the weather, let's say the weather is very sunny, which was the highest amount of water that you collected in a day? It was 200 milliliters.
Yes, we will join you outside shortly. My question to you is, what exactly did you use that upper layer? What is that? Glass or plastic?
Glass.
Glass sheet.
Yes.
So the sunlight penetrates through the glass, hits the water, evaporates, and then it condenses. Such a thing looks a bit advanced. Who came up with this idea?
Well, we came up with this idea with the teachers.
With
our teachers.
So who came up with it originally? Whose original idea is it? Who between the two?
Both of us. We just brainstormed.
Is that how brainstorming? Can the same idea appear between two people's minds? I mean, who was the originator of the idea?
This was we just discussed and then we came up with the design of how to.
So you discussed and you came up with it?
Yes.
Okay, fine. We are very eager to see what it looks like. But before we go, what was the purpose of that space up there? I can see the glass there. That frame? Okay. Let's go on.
Thank you. When the water condenses over here, it's like
Water in there and clean water here. So you did not put this water here today? But I can see the condensation. Come back.